Solar cells have the ability to harness the energy from the sun and convert it into usable form of electricity. This is only achievable during the daytime, when there is sun available. Then for night usage of this free solar energy, one needs a storage medium, which is usually battery. During the day, he can use the energy free and store some energy through battery. During the night, when there is no sun, he can use the stored energy from the battery. But many a times when the solar system is connected to battery in one circuit, at night the solar panels easily draws back the energy from the battery. To avoid that, one must disconnect the battery from the solar circuit. Solar charge control is one system that can be used to automatically cut off the circuit for the solar panel when there is no sunlight, hence prevent manual backload of circuit disconnection. Therefore, how does a solar control work? Solar charge controller is a critical component in solar power system, especially in off-grid or hybrid setups where batteries are used to store excess energy generated by solar panels. Its primary function is to regulate the charging and discharging of batteries. Today's project, we are going to run the basic solar charge controller, which has the ability to disconnect the circuit to the battery when there is no sun, to prevent the battery from discharging current to solar panel. Also, the controller will have the ability to read amount of current released by the solar system and display it. First, let's simulate the project inside the Pro2 software. As we can see, we have a solar panel. We have current meter. We have current sensor, precisely ACS712. We have resistor. We have microcontroller called Arduino Uno. We have LCD, that is liquid crystal display. We have relay. We have photodiode. We also have second circuit to help the photodiode work. Also, we have the load. As we can see, when we run the project, the LCD displays the current from the solar panel. Also, photodiode is connected such that when there is sunlight, it energizes the relay, and when there is no current, the relay is de-energized, hence disconnecting the circuit. I have shown through this push buttons. When there is sun, that is push button closed, the relay is energized, hence the battery is charging. While when there is no sun, push button opened, the relay is de-energized, hence battery can neither charge or discharge back to the solar panel. Now let's see the components. We have a photodiode. Its terminals are connected to the relay coil terminals. The relay has normally closed and normally open terminal. The circuit from the solar are passing through the normally open terminals of the relay. This is how it works. The solar panels releases the current through the normally open contacts of the relay. And since the terminal coils relay are connected to the photodiode, which is a sensor, the photodiode sends the current which energizes the coil of the relay, which in turn closes the contacts, hence the current reaches the battery. Immediately the sun is off. The photodiodes cannot generate current, hence the coils of relay de-energized, hence disconnecting the circuit. Photodiode is a p-n junction that consumes light energy to produce an electric current. A photodiode is subjected to photons in the form of light, which affects the generation of electron-hole pairs. If the energy of the falling photons is greater than the energy band gap near the depletion region, the electrons' holes are separated from each other due to electric field, hence generation of current. Also, a microcontroller is used, precisely Arduino Uno. It connected to the LCD and also current sensor. Base anatomy of Arduino consists of the microcontroller. This is the brain of the Arduino system and is the component that we load program into. Think of it as a tiny computer designed to perform specific tasks. We have USB port used to connect your Arduino board to a computer. We have USB to serial chip. This is what makes it possible to program the Arduino board. We have digital pins that use digital logic, for example 0 and 1 or low and high. We have analog pins that can read analog values, usually 0 to 1023. Then we have 5V/3.3V. These pins are used to power external components. We have ground or negative, which is used to complete the circuit. We have VIN, stands for voltage in, where you can connect external power supplies. The program is loaded into Arduino, then it executes accordingly. Here the Arduino is able to read analog signal from the current sensor and output it through the LCD. In the controller we have current sensor. Here we have used ACS712. It is based on the principle of Hall sensor. According to the principle, when a current carrying conductor is placed into a magnetic field, a voltage is generated across its edges, perpendicular to the direction of both the current and the magnetic field. Out of the current sensor is connected to analog pin of Arduino. We have LCD, which is liquid crystal display. This is the electronic display device that operates by applying a varying electronic voltage to a layer of liquid crystals, thereby inducing changes in its optical properties. It has VSS, which is ground terminal. It has VDD, which is power supply to the LCD module. It has VO for contrast adjustment. It has RS, which is register select, for selecting data and command modes. It has RW, that is for control pin for selecting between read and write operations. It has E for enable. This is clock input for latching data into the LCD module. It has D0 to D7, which is an 8-bit bidirectional data lines for transferring data between the microcontroller and the LCD module. We also have anode for positive voltage for backlight, and cathode, which is ground for backlight. I hope you found this video informative. If you did, kindly subscribe, like, and share. See you in the next one.